Welcome to DP Tutorials by Donny Jerwa. In this teaching module, we will emphasize and accentuate on one topic, which is the electric motive force and the terminal potential difference of a cell. Now, we have to know that a cell consists of two electrodes. One electrode which is known as the positive potential, and the other electrode which is known as the negative potential. This electrode of the cell which is at a positive potential, this is known as the anode, and this potential of the cell which is at a negative potential, this will be known as the cathode. Before I discuss the concepts of electromotive force and terminal potential difference, which is also known as the voltage, let us first understand the key features of what is a cell. Okay, a cell basically is nothing but a type of device which consists of two electrodes. Okay, which consists of two electrodes, namely the positive electrode, which is known as the cathode, and the negative electrode, which is known as the positive electrode, which is known as the anode, and a negative electrode, which is known as the cathode. Now, in this picture, we have, this is the type of a cell. Okay, we have a cell. This is your cell, and this is your cell. The structure of a cell. This is your cell, and we have two types of metal plates. The metal plate in which it is a positive potential, this is known as your anode. Okay, and the metal plate which is at a negative potential, this is known as your cathode. That is why the symbolic representation of a cell is given in this form. Okay, we have the in this form. So this will be positive and this will be negative. The type of that vertical line which is larger, that will represent positive, and this lower vertical line, that will be negative terminal. Now essentially there will be some chemical solution within the cell. This chemical solution within the cell is known as our electrolyte. Okay? It might be different types of electrolytes. Okay? So over here, suppose if I consider a solution of sodium chloride, a solution of sodium chloride, upon dissociation, it will give you these ions of Cl plus, and it will give you one Cl minus. So when we pass electricity in this cell, that means all these positive ions will attract, towards the negative electrode, which is known as the cathode, and all these negative ions, which is the Cl minus ions, they will be attracting one. They will be attracting this the positive plate, which is known as the anode. So negative ions, which is known as our anions. Don't get confused. Okay, anode is positive, whereas anions are what? Anions are negatively charged particles. So these cations are positively charged particles, whereas the cathode is the negative electrode. It is not negative electrode. So this is the structure of a cell. Basically, a cell are of different types. We have what we describe as the primary cell. Okay, I will write this as number one. We have the primary cell. Okay, and also we have the secondary cell. These are features related to cell. So let's just study upon what is this primary cell. A primary cell is essentially that type of cell which you cannot recharge, like in the case of a pencil battery. If we have a battery of this form, a pencil battery of that form, we use this in charging which is connected to any sophisticated device, especially when we have the remote control. If you look inside the remote control, you have these type of devices which is known as the pencil battery, and these pencil batteries are nothing but examples of primary cells. So these primary cells you cannot recharge after use. Inside these primary cells, we have a structure of this form, okay, which we have this upper end of that metal cap, which is your positive, and if it is positive, that means it is what? It will behave as your anode. Okay, the upper end will behave as your anode, and the lower end, this upper end will behave as your anode, and the lower end, this lower end, the lower bottom plate will be at a negative potential, and this will be what? This will be at a positive potential. So the lower end will behave as what? This will behave as your cathode. Okay, this will behave as your cathode. So likewise, that means inside that battery we'll have these types of chemical potential, chemical solution, okay, chemical solution, which is in the form of what? Which is in the form of electrolyte. And over here we have this type of solution, or we call that as an absorbent material. Okay, we call them as an absorbent material, as in the form of ammonium. So, and also we have another type of oxide or material, which is known as your manganese oxide. So from here, when you look at the structure, it is very clear that this will give you, there will be some chemical reaction which takes place between ammonium, okay, ammonium and this manganese, okay, ammonium and this manganese, and it will give rise to some kind of an electricity within the cell. So it will generate its what? It will produce its own electricity due to what? When the cell gets discharged. Okay, when the cell gets discharged, so it will produce electricity. Okay, it will produce electricity. So from here, these are some of the intriguing terms that we need to know. And a primary cell is nothing but that type of cell which cannot be easily recharged, okay, after use. And once you use it, these are called use and throw battery. Once you use it, that means it can be discarded after use or discharge. Most of these primary cells, they will use what? They will use an electrolyte, which is an absorbent material. So from here, there will be no free or liquid electrolyte, which means that inside these primary cells, mostly it is an absorbent material, okay, absorbent material, which means once the electrolyte is consumed, that means the cell will loses its energy or loses its charges. Now another type of cell is defined as what? As our secondary cell. Our secondary cells are typical examples of batteries where you can easily recharge. Okay? You can easily recharge after use, and you can recharge these after use because they will discharge. Okay? They will discharge, which means that if you have if you have a negative plate in this form, we have the positive potential and we have the negative potential. This is known as your cathode, and this is known as your anode. That means from here, if you connect across a bulb, again, that bulb will be lightened. If this is the bulb, that means the bulb will be lightened, and when it get lighted, that means all those negative ions which attracts the positive plate and all those positive ions which attracts the negative plate, that means they will give rise to some kind of an electric field, or there will be some kind of what? Or some kind of a discharging action. We call that as the discharging action. And once these ions are used, that means the strength of the charge inside the cell will decrease. The strength of the charge inside the cell will decrease. So how you reuse it? We can reuse it by passing electric current through that circuit, but in the opposite direction. But always remember that in a cell, we have the positive potential and the negative potential. That is the symbolic representation of a cell. This is the symbolic representation of the cell. The current in the external circuit always move from positive to negative. Suppose this is the circuit diagram. That means it moves, the current I always moves from positive to negative. But when you recharge, you have to recharge in the opposite direction, which means from negative to positive. Current moves from positive to negative, and when you recharge, you have to recharge in the opposite direction, which means from negative to positive. The discharging action always takes place. Okay? This discharging action always takes place from 1 from positive to negative. Okay? From positive to negative n. While when you get charge, you have to recharge it in a direction which is opposite to that. That means when you recharge, you should recharge from the negative n to the positive n. That means from the negative n to 1 to the positive n. So these are the examples related to a cell. A cell will have two electrodes. One electrode which is known as the anode, which is your positive, and the other electrode which is your cathode, which is your negative. Cations will attract the negative, and the negatively charged ions will attract the anode. So all these negatively charged ions are known as anions. All these positively charged ions are known as cations. So now we will discuss about the terminal potential difference and the EMF of the cell. What is that terminal potential difference and EMF of the cell? The EMF of the cell is nothing but that potential difference between the terminals of the cell when it is delivering current from the cell. So when you deliver current from the cell, when no current is delivered from the cell, that means that is known as your potential difference, which means that if you have a cell and if you don't connect it, which means that the cell is an open circuit. Okay, the cell is in an open circuit. Suppose I have this key, and if I don't insert the key, that means if I don't insert the key like in that way, that means no current will flow in the cell. So this is the type of circuit in which we call as an open circuit. So in an open circuit, there will be no current. In an open circuit, there will be no current. So since there is no current, since in an open circuit there is no current, so which means that the voltage or the potential of the cell is maximum. So when the potential of the cell is maximum, that is known as the EMF of the cell. Okay, this is known as the EMF. Suppose if this battery, suppose if that battery has a potential of 1.5 volts. Okay. This 1.5 volts is what is defined as your electromotive force or the EMF of the cell. So that EMF of the cell is that type of potential in which there will be no current. No current will be delivered to the cell, since the cell is in, or the circuit is in an open circuit. Okay, and also remember that this EMF of the cell is that work done in moving a charge. Okay, the work done in moving the charge. This EMF of the cell is the work done in moving a unit positive charge once around the closed circuit containing the cell. See from here, okay? If I have this cell, that means besides the cell there will be some resistance. Okay, there will be some resistance within the cell, and this resistance within the cell, is known as what? It's known as the internal resistance of the cell. And from here, that means we used to represent the internal resistance of the cell by this symbol, and that will be denoted by what? And that will be denoted by small r. This is known as your internal resistance of the cell. If I put this key and if I don't insert that point, that means it is an open circuit. So what is that EMF of the cell? The EMF of the cell is the work done on a unit charge in order to drive in. Once around the closed circuit containing the cell. So from here, remember that there will be charges. And this current will be moving. There will be charges, and all these charges will be moving in one particular direction. Now, again, suppose if in the cell we have a key, and then I insert that plug. When I insert the plug, what will happen? Current will flow inside this circuit. And besides that, also remember that with respect to this cell always have some internal resistance. Why we have this internal resistance? The internal resistance is because, okay, the internal resistance is because it is nothing but the resistance offered by the cell. Okay, the resistance offered by the cell due to its discharging action, which means that the movement of charges is obstructed, which give rise to the resistance of the cell. Why we have this resistance? Because charges are obstructed. Okay, charges are obstructed. We have this R is known as R1, our internal resistance. This is known as our internal resistance. And this internal resistance it arises because of what? It arises because charges are being obstructed. It arises because charges are what? It arises because charges are obstructed during their motion. When I say obstructed, that means they are being resisted. Okay, they are being resisted. So when charges are obstructed during their motion, so that will give rise to what type? To the resistance of the current flow, or we define that as the internal resistance. So from here, this EMF of the cell, okay, this EMF of the cell is that type of voltage when no current is delivered in the cell, or the cell is in an open circuit. Okay, it's in an open circuit. So the potential should always be maximum. Okay, the potential should always be maximum. And from here, this potential of, suppose example 1.5, this potential is independent of the circuit resistance and depends only on the nature of the electrodes, which means positive and negative, and of the electrodes and the electrolyte. Inside the cell, there will be a chemical solution, which is known as the electrolyte. The term EMF is used for the source of voltage, just the source of voltage, which means that when you buy any pencil battery, that means when you check the voltage, that voltage which is imprinted on that dry cell, that is known as the EMF of the cell, or we define that as the source of voltage. Then, terminal potential difference. What is this terminal potential difference? Now, I have explained over here that when the circuit is closed, or when the electric circuit is closed, then there will be current flow. Okay? When the circuit is closed, that means there will be current flow. There will be current flow. So there will be current flow. If there is current flow, that means the current will move in this direction. Current I will be moving on that direction. So the potential, if I have, suppose, some resistance which is connected over here, that voltage between the terminals of the cell, these are the terminals of the cell. The voltage between the terminals, I can connect this via what? Via a voltmeter. When I connect this via a voltmeter or through a voltmeter, even if the voltage of this battery is around 1.5 volts, this voltmeter will reach a reading of around 1.2 volts. Why there is a decrease in voltage? The reason is because the current is drawn from the cell in order to move the charges. Okay, So the potential difference of the cell between the two terminals, when the cell is closed, or when current is drawn from the cell. Always remember, current is drawn from the cell in case of when the circuit is closed. There will be no current drawn from the cell when the circuit is open. So it is that voltage between the 2 points of the cell. These are the 2 points of the cell. Voltage between the 2 points of the cell, that is known as your terminal potential difference. And also it is independent of the circuit resistance and any type of circuit. Now, what is this terminal potential difference? It is the work done in moving the unit charge, driving in from positive to negative terminal of the cell. So when you drive charges, you should always drive charges from the positive to the negative. Why? See, current always flows from positive to negative end. So this flow of current is nothing but the flow of what? Is nothing but the flow of positive ions. Okay? Flow of positive ions. This will give rise to what is known as our conventional current. Okay? This I is nothing but your one conventional current. Conventional current. Conventional current. So the terminal between these 2 points of the cell, if you find the voltage, that is known as your terminal potential difference. Between these 2 points of the cell, if the circuit is open, that means that voltage is known as what? EMF of the cell. Don't get confused. In this case, the circuit should be closed, the cell should be closed, and in this case, the circuit should be what? The circuit should be open. Now, when you are moving, when current is moving, that means there will be one. You are doing some work done, there will be movement of charges or work done on net positive charge. So that is defined as your terminal potential difference through the load resistance or external load. Then this internal resistance I've explained. What is the internal resistance? Internal resistance is nothing but the resistance offered by what? Offered by the cell is known as your internal resistance. It depends upon what? The distance between the plates. If I have this plate and this plate, that means positive and negative. It depends upon what? The distance between the plates. It also depends upon what? The area of the plates. Okay? The area of the plates. It also depends upon the nature, concentration of the electrolyte. What will be the nature of that electrolyte? Okay? What will be the nature of that electrolyte? And also it depends upon the temperature of the electrolyte. Okay? In this case, we have this electrolyte over here, we have this electrolyte over here, and then the internal resistance itself depends upon the nature of the electrolyte. That means what type of chemical substance is being given. Either you put any type NaCl, or it might be ammonium nitrate, AgNO3, okay, silver nitrate, and so on and so forth. So it also depends upon the temperature of the electrolyte. Okay? So these are some of the important factors that we need to know. And the difference between EMF and voltage is that when you look from the circuit diagram, the EMF of the cell is also known as what? The electromotive force. Okay? Electromotive force. So this is your EMF of the cell, or the electromotive force. It's that type of energy which forces a unit positive charge, okay, which forces a charge to move from the positive terminal to the next. See, this charge, suppose if I consider a positive charge, it might be NaCl, okay, NaCl or any type of charge. It moves from positive, indicated by this arrowhead, and it moves to the negative terminal of the source. Which is the source? Okay, what is the source? This source is nothing but the battery. This battery is our one. This battery is your source. Okay? So that EMF will be maximum. Potential in this case will be maximum. Now, what is voltage or terminal potential difference? The terminal potential difference is measured between these two ends, okay? Between these two ends of a load resistance. The voltage is the difference in electric potential between 2 points, okay? Any points. So let E and B be the 2 points, which is equal to the work done per unit charge. So what is work done per unit charge? When I say work done per unit charge is nothing but what? Electric potential, okay, against the electric field to move a test charge to these 2 points. So from here, that is known as your voltage. Voltage is work done per unit charge. You are moving the charge from one end of the conductor to the other end of the conductor. So even from here also, this will be the direction of what? Current flow. Okay, this will be the direction of current flow. So in EMF of the cell, it will be in case of open circuit, and potential difference of voltage will be in terms of what? Closed circuit. So from here, these points of difference are very, very important for you to understand. So what is EMF of the cell? The EMF of the cell is nothing but the maximum voltage, maximum potential between what? two electrodes. When I say two electrodes means what? Anode and cathode. Okay. What is anode? Positive electrode. What is cathode? Negative electrode. When the cell, very important, very important, okay, when the cell is an open circuit. Now, what is this potential difference or simply voltage? Potential difference or simply voltage, I can write this EMF E by that. Now, the potential difference between 2 points is the difference of potential between these 2 points in what? In a closed circuit. It should be in a closed circuit. EMF is independent of the resistance of the circuit, but it depends upon the nature of the electrodes and the electrolyte. This depends upon the resistance between 2 points of the circuit and the current flow through the circuit. It depends upon those 2 points. Like over here, if I have the cell, okay, and if I consider 2 points, E and B, it depends purely on these 2 points where current is flowing. Okay? Current is flowing from point A to point B. So it depends upon these 2 points of the circuit and the current flowing through the circuit. Potential difference. The term EMF is used for what? The source of the current. What is the source of current? The battery is the source of current. This battery is the source of current. That is why it's denoted by E. And from here, suppose if we want to find the voltage, that means we have to have what? We have to have a voltmeter in order to find out what is the voltage. Potential difference can be measured between what? 2 points. See over here, this is the point A and this is the point B. How will you find the potential difference between these 2 points A and B? By using the voltmeter. So you can measure that. You can measure that. So over here, what is this movement of current is nothing but the cause, and the generation of this potential is nothing but the effect. So these are some of the important things that we need to focus upon, so that it will give you a clear emphasis of the relationship between terminal potential difference and voltage. But also remember that the EMF of the cell, okay, the EMF of the cell is always very large than the terminal potential difference. See, if this EMF of the cell is 3 volts, then after you supply current in the circuit, that means when you check through a voltmeter, that means it will be suppose around 2.8 volts, which means that the EMF of the cell is always greater than the potential difference of the cell in the external circuit. This is the very important point. EMF of the cell, EMF, is always greater than the potential difference or the voltage. So just go through those lectures so that you will understand. Thank you.